There's this popular fiber that you can find pretty much everywhere, from your morning oatmeal to all sorts of supplements. It's called beta-glucan, and it sits at this fascinating crossroads of our immune system. So what's the deal? Is it this powerful ally, or could it actually be a foe? Well, as we're about to see, the answer is anything but simple.
Okay, so let me ask you this. In a world that feels like it's full of environmental toxins, could something as simple as a dietary fiber act like a bodyguard for our immune system? It's a really powerful idea, right? And thankfully, researchers have been putting that exact question to the test.
But as it turns out, the science here tells a really complex, two-sided story. It's one of those classic cases where the details, well, they matter a lot. So let's really dive in and look at both sides of this coin.
First off, what exactly is beta-glucan? Well, at its core, it's a type of soluble fiber. You find it in the cell walls of some very common things: yeast, mushrooms, certain bacteria, and even grains we eat all the time, like oats and barley. It's basically a fundamental building block for them. All right, let's kick things off with the hero side of the story, beta-glucan as the protector. This is where we see its incredible potential to act as a serious bodyguard for our immune cells.
I mean, think about it. Every single day, our immune system is on the front lines, fighting off all sorts of threats. And some of those are environmental toxins, like mercury, which we know from research can have these dangerous immunosuppressive effects. Basically, it just dampens our body's natural defenses.
And this is where it gets really interesting. In an animal study, where researchers are looking at mercury poisoning, they found something pretty remarkable. When they fed mice a beta-glucan that came from yeast, it significantly pushed back against the immune-suppressing effects of the mercury.
And wow, the effect was just stunning. Look at this chart. Mercury exposure alone basically cut the mice's immune function by more than half, down to 45%. But in the mice that also got the yeast-derived glucan, their immune function shot back up to 90% of normal. I mean, that is a huge, dramatic recovery.
And get this, it wasn't just mercury. Other animal studies found it could reduce the immune damage from common contaminants like PFOA and PFOS. In another study, a yeast-derived glucan even helped protect mouse bone marrow from DNA damage caused by a really powerful drug. The pattern in these studies is pretty clear, right? When eaten, beta-glucan seems to be a really potent protector.
Okay, but that's only half the story. We've got to move to the flip side now and see how this very same molecule can actually act as a provoker. This is where things get really, really nuanced. So it turns out the most critical factor, the absolute game changer, is how beta-glucan gets into the body. When it's inhaled, say from things like mold or dust, it's been linked in humans to some serious problems: lung inflammation, chronic bronchitis. But when it's eaten, like in those animal studies we just saw, it appears to be safe. The way it gets in is everything.
And yeah, we're not talking about a minor irritation here. Research actually points to inhaled beta-glucans as important causal factors in these negative lung reactions. This is a significant health concern, not just some small side effect.
And just when you thought it couldn't get any more complicated, it does. Beyond just how it enters your body, beta-glucan can have some completely unexpected and frankly dangerous interactions with other common drugs.
Okay, so check this out.
In one animal study, researchers took a very common anti-inflammatory drug and combined it with beta-glucan. The result was absolutely shocking. Mortality rates were significantly elevated. The researchers themselves were floored. They called it a completely unexpected result. All of a sudden, our protector molecule became a dangerous provoker.
So, what are we supposed to make of this? We've got this Jekyll and Hyde molecule, acting as both a protector and a provoker. And this really leads us to the core lesson here. Not all glucans are created equal. The devil is truly in the details.
Which brings us right back to where we started, right? Is it an ally or a foe? And the answer we're seeing is a big, fat it depends. It depends on the source, it depends on the purity, how it gets into your body, and what else is going on at the same time.
And nothing shows this better than a study that compared a bunch of commercial beta-glucan products. Scientists measured how well each one stimulated immune cells, and the results? They were just all over the map. You had some yeast and mushroom-derived glucans that were super active, and then you had others that showed barely any activity at all.
I mean, just look at that number. We're talking more than a 10 times difference in potency. The most active one was over 10 times more powerful than the least active one. That's not some small variation. That is a massive, massive gap between products all being sold under the same beta-glucan name.
So what gives? Why the huge difference? Well, the researchers basically said it all comes down to quality. They found that the really purified, high-quality glucans have what they call pleiotropic effects, meaning they have multiple, wide-ranging impacts on the body. But the poorly made ones, they might have little to no biological effect whatsoever. Purity and processing are key.
Okay, let's tie this all together. When it comes to beta-glucan in your immune system, if there's one thing you should take away from all this, it's that context is absolutely king.
So here are the crucial points to remember. First, the route is everything. Eating it is not the same as breathing it in. Second, the source and purity matter immensely. As we saw, not all supplements are created equal. Third, the potential for it to be a protector is real. Those animal studies show a clear ability to counteract certain toxins. But finally, and this is so important, these interactions are complex. That shocking study with the anti-inflammatory drug just proves we need way more human research to fully get our heads around the risks and the benefits.
So, all of this leaves us with a really interesting question to chew on. As we learn more and more about molecules like beta-glucan, maybe the whole conversation around our immune health needs to shift. Maybe the future isn't about just blindly boosting our immune system, but about achieving a much more precise and intelligent balance. It's a complex system, and as we've seen, the tools we use to influence it require a really deep understanding. Thanks for digging into this with me.